All right. Hi, everybody. This is July 26, 2019. We are having one of our semi-regular, although they haven't been very regular, Above Science Cloud webinars to talk a little bit about services and features available on the Science Cloud. And today we're going to have Scott Sinno, who's a systems administrator for the NASA Center for Climate Simulation, NCCS Science Cloud, talk a little about the scheduler that is available on the cloud, which is called SLURM. And then after he presents, we're also going to have Matt Stroud, who's another NCCS employee, talk about a cloud filtering algorithm that he's been working on this summer. And we have a little bit of time at the end where he can talk about that. And then we'll also have some time for question and answer. I'd like to give a few more people time to come on line. So far I see scientists. I see Adriana Foster. Let's see. I see Mark Chopping, Pat Burns, and Stefano Potter. So I'm glad you guys could join us. And we'll give it a few more minutes to see if a few more people come online. But however, if any of you guys have anything you wanted to ask about, we could take a minute or two now to ask any burning questions that you had. See a few people typing there in the chat box. I'll also just say that we like for these webinars to be a little interactive, so if people have questions, you can feel free to ask them during the webinar, and I'll monitor the chat box and we can make sure that the speaker knows that you've asked a question. Adriana says, I haven't checked out the website in a while, so I should look there, but I was wondering if there would be /is a page about SLURM commands available on ADAPT versus those that are available on Discover.
We don't yet have an ADAPT specific page for that. However, sorry?
I think you might have some guidance.
Yeah, we do have some. I don't think it's as in detailed as we want. I'm looking it up now.
I was going to stick it in that chat box unless you've got it. Here we go.
It's in the works, and part of what we'll be doing today is going through a PowerPoint presentation of SLURM usage, which I believe Elizabeth can make available through the web for future reference, but I expect it to become a part of an augmentation to the ongoing documentation.
So there is...
Yeah, that link is the same one I was...
Okay.
Just the same one.
All right, so in the chat box there is a link now. And then also Pat Burns asked a question. Can you remind us again of the ASC specs and computing resources we have available? How many machines, typical memory, CPUs per machine?
Probably the easiest way to ascertain that is to look at the SLURM configuration file that's on the nodes, which I actually included in the PowerPoint presentation coming in. SLURM is available on any of the above nodes that can be launched. It's not, the above nodes themselves are not considered part of the compute pool for SLURM. The beyond nodes are for that. We have 4 above nodes allocated to facilitate interactive jobs or testing of jobs that you might want to run in bulk. And then there are, I believe, 29 beyond nodes currently in SLURM.
Well, I think now it's 5 after, so I think we have everyone we're going to probably have online. These are recorded, so if someone misses it, they can always catch it later. We'll put it up on the website. So I think we'll just turn it over to Scott and let him share his screen and go through his PowerPoint and his demo that he's going to do. So Scott has been working on the Science Cloud since its inception, I think, pretty much, right, Scott?
True story.
He's
back in 2013.
He is a systems administrator with NCCS, and he's been working on this for a long time. So we're going to let him take it away and explain this to us.
All right. Sue, can you
show the power? Put it into slideshow view. Down at the bottom on the, yeah, there you go. I usually do on the bottom on the right next to that Zoom bar. There's like a little projector icon.
The Adobe Connect bar?
Oh no, it's below that.
In PowerPoint.
In the PowerPoint itself. Or it's also up at the top, yeah.
View slide.
I think at the top, I think you do slideshow. At the top, instead of view, I think go to slideshow.
It's right above insert.
And then from beginning.
Yeah.
Oh, hold on here. Now we see the presenter view. Can you do display settings? And then I think there's a way to, so we all see it. Or maybe only I saw the presenter view. Probably
no, the presenter view is what came into my screen. And
okay.
How many screens do you have?
I have 3 monitors. So when I did that, it actually cast the main view of the other monitor.
You have to put it on a different monitor, either your screen share or the PowerPoint window itself, and then hopefully it puts the right one.
But it moved the. Is this a real problem to read?
Yeah, we can read this. This is fine.
Okay. I mean, I don't want to spend 10 minutes trying to sort out what my issue is here. So why run SLURM in the first place? Since we have an abundance of ABoVE users, it provides a means to schedule jobs and fair sharing of the resources available. It also provides a mechanism for us to try to use those resources more efficiently by letting the scheduler handle what's running at any given time, rather than having people try to sort it out and coordinate amongst themselves. And it also facilitates scaling very well. It's not, you wouldn't want to have to SSH to 30 different nodes manually to try to invoke jobs. And it's even, granted, utilities like PDish can get you around that requirement, but it's still more arduous than trying to use a full scheduler like SLURM. The most useful commands that that I believe you'll find are sinfo, which shows you some simple info regarding what nodes are available and out there. SQ gives you a little more detailed breakdown of what jobs are currently running, what nodes they're using, who is using them. SBatch is the primary means of submitting batch jobs up into SLURM, and the scancel utility will let you cancel or terminate a running job you own if you realize there's some reason to do that. So I've included the most basic type of SLURM batch job here in my little coin script. This is a very simple compiled binary that runs, and it effectively takes up a single processor. So you can see here I've defined the most basic parameters to define it. You need to supply a job name, the number of tasks that you're that you're defining. This export all flag explicitly says to convey all your current environment variables into the job, which is often quite important, we found. And finally, just the srun invocation at the bottom. So you can see that just by invoking sbatch against that job script, that gets into the job queue. We have some tools that you may not be aware of to help you characterize the resource requirements for your job. Ganglia, which is available via this link here, and I'm going to switch to my Ganglia page. Can everyone see that? And Ganglia oversees and collects resources being utilized for the entire cluster. The above VMs are defined in a subcluster here under this left-hand column. So you can click above shared VMs and we'll see what resources we have allocated to the above project. You can see here we've got above the beyond nodes, some of which are currently in use as these blue areas here indicate user CPU utilization going on here. Back to PowerPoint. Top is also another, easy way to ascertain what resources your job may be requiring. And in response to a question that we got earlier, the easiest, SLURM does give you some commands to let you see what's out there in the pool and what resources each node has, but I found it's easiest to just look at the SLURM configuration file itself. And I'll pull up an example here. And this is available on any of the above nodes. You can reference this. But if you just go down to the node name list, it'll tell you exactly what's there, how many processors it has, and how much memory. In the case of the current Beyond cluster is entirely homogeneous in that regard, with 6 processors and roughly 60 gigs of memory per node. Those units are in megabytes. What originally inspired me to conduct this little session was noticing that we do have some jobs that get put out there that are running across more nodes than are needed. The current limitation for each user is 10 nodes at a time. But it's possible to, without putting any tuning parameters in, it's possible to kind of misuse what's out there. For example, if I go back to this coin job, and we can look at the script here, coin.j. One way I can run this is just to sbatch coin.j, coin.j, coin.j. And now what's happened is I've spread this job. I'm running this job 3 times on 3 different nodes. So I've used 3 out of my allocation of 10. But if we open a shell on, say, beyond 113, it's not going to let me yet. That should work, and it doesn't. Maybe it has to be an interactive mode or something. Another way to ascertain what your job requirements are is simply to run them locally on. Sorry, that wasn't my intent. Just dump that to dev null. And we can see with top that this simple job only takes up a single processor, consumes almost no memory at all. So I don't need to be using 3 whole nodes for these runs. Let me cancel these real quick so I'm not hogging resources. So we can modify the job script to make better use of what's out there by more explicitly telling our SLURM batch script what the requirements are. So I want to run 12 invocations of this program, but each one only takes one processor, and the total memory required is only half a gig per. So I specified all that in the batch file, and if I make those same changes on the existing job script, that at 12 and that at 12, and I resubmit this, now it's only using 2 nodes to run 12 of those coin sessions, because each node has 6 processors. So this job will actually fit on 2 nodes now, the way I've defined it. Questions? Hello.
Hi, I see a question from Mark Chopping, who said, how do we know what memory in megabytes to specify for the PGC ortho routine, for example?
So the best way to do that, I'm trying to figure out how to get the Adobe Connect session back. There we go. Aha, all right. The easiest way to do that is to run the job. I would advise running the job manually, interactively on one node, and then looking at either top or preferably Ganglia, because Ganglia captures data for the entire run. It's not just a spot check of how many resources it's using. You can look at Ganglia and let me take the screen back and actually do this. Sorry. Where did my job go? Beyond 113114. So if I go to Ganglia now and look at beyond, well, it might already be finished. These are very quick jobs. Yeah, it is already finished, so I missed it. But you can see where this blue bar spikes right up to the top of 100% for the node. Additionally, you can see that the memory requirements didn't spike at all due to the nature of the job. But if it did have the larger memory requirements, that would be much clearer through this Ganglia screen.
Other questions for Scott? All right. Well, has
Hey, Liz,
anyone?
actually, Liz, let me jump in. So you post this recorded webinar, right?
Yes. Mm-hmm.
Okay, but I think we want to take a look at what Scott's got here and maybe put that on the website as well. So we have the presentation there, the PowerPoint.
Oh, yeah, he gave me his presentation, and I'll post that along with the slides on the website.
Okay, I mean, I was thinking we could do it on the NCCS website as well.
Oh, yeah. Mm-hmm.
Yeah, okay.
So for those of you that are on the webinar, our scientists on the webinar, how many of you are using SLURM already? I know Adriana is using it. What about Pat and Stefano and Mark? Are any of you guys using it already? All right, so Pat uses it, and Stefano also uses it. Have there been any things that have come up while using it that you want to learn more about? All right, it looks like Stefano and Patrick use it quite a bit. Mark, shopping not yet, but I think you will soon once your student joins you. Well, if we don't have any other, oh, here we go. Stefano said, I think one thing we can also do to improve performance is to spread jobs across CPUs on an individual node instead of submitting one job per node.
True, and that's exactly what I tried to demonstrate in that in that little run I did. You know, it's possible for me to take 12 nodes to do my little coin job and have one run on each, but it's much better to specify, you know, a SLURM batch script that makes more efficient use, such that so that I've conglomerated all the runs onto 2 nodes there at the end instead of 12.
Pat mentions I've found SLURM arrays to be very helpful for processing many files with the same script. And Adriana has a question. So if I submit one very simple job that couldn't be spread out, would that node then be barred from other people using it?
Yeah, excuse me, I'm having some serious throat congestion today. Sorry, the scheduler does node lock jobs. So if you have a single processor job running on, say, beyond 105, beyond 105 is no longer eligible for other users to submit jobs there. It's the same way Discover configures resource locking on their nodes, and they've had a long history of running SLURM, so I followed suit on that. I think the problem they ran into with letting multiple users share the same node was that, you know, it's possible for user A to perhaps specify inaccurate parameters in the job script and send the node crashing down, and then user B becomes an innocent victim of it.
I see Adriana still typing. We'll give her another minute. Also, now's probably a good time to ask any just kind of general Science Cloud questions. Matt Stroud's presentation will be more focused on a specific application that he's creating. So if you have other just general Science Cloud questions, we might be able to ask some of those now. Oh, and here, Adriana's finished typing. I think I mentioned this before, but would anyone be interested in getting some sort of Slack channel for SLURM/Beyond users? We might be able to help each other out with scripts and scheduling stuff.
Yeah, Adriana, we had talked about this at the science team meeting, and it's just always a challenge to get Slack stuff here at NASA. I wish it were easier, but I honestly haven't pursued it as much as we have. Do you have, Liz? If you know somebody who's done this, I'm all ears.
Well, I think NASA has a Slack system that they use. I think there's a GIS group on one of them. I think.
Yeah, I see Jim is typing. Yeah, Jim is typing. So.
Jim asks, are any of the SLURM users also utilizing the Windows environment for specific processing? Pat says he's not, Adriana's not. Stefano says he usually prototypes his code in Windows and then sends the final script through SLURM. And Mark Chopping is not. Jim, do you know about Slack on the, I think that it exists for people at NASA.
Yeah, the only thing that I've used NASA Slack for though was the Goddard Developers Group. I don't think I ever did anything with the GIS group out there.
Okay. But it seemed like it was an approved technology, wasn't it, that they were using? Yeah.
It was, and then they backed off their support of it.
Oh, okay. All right.
Which doesn't mean we can't use it. It just means that they're not encouraging us anymore, so it's harder to get to. I think I even heard somebody tell me, and that was not official, that they're not allowing any new groups. But if I could find somebody who could answer my questions, I would absolutely follow up.
I wonder who we could ask, if it would be like Code 700, or who would know if that's an approved, NASA system.
Yeah, actually, maybe Jeff Simpson. He might know, because he's our, I'm going to ask Jeff.
All right.
Writing an email now, sort of. Finally connected. No, it's not. I can't get 0355 to talk to me today.
All right. Well, I think that looks like we've gotten all of our questions at least addressed for SLURM. Any other Science Cloud questions, or should we move into Matt's presentation? Adriana is noting that Intel was updated today, and she wants to know if the geodatabase also is going to be updated.
Oh, yeah, I'm staring at it, thinking,
All
wait,
right.
that's right.
GDB, so sort of. GDB is that's a stock OS utility. Let me take a look. So we're looking to update the above and beyond nodes to the next generation of Debian OS, as we're aware many of the tools have become severely dated. Does it? Let me confirm or deny that. There may be an Intel specific version. 1 second. GDB-IA. I was not even aware of the existence of that. Yes, looks that way.
All right, that was quite a lot in the chat box. So it sounds like there is an Intel-supported version of GDB that's available, and it's already accessible, but we just didn't realize it?
Yep, I didn't know.
Right.
I was not even aware that was a utility that Intel provided these days. Although it looks like I'm trying to run it now and it's erroring on me due to inability to find the shared object file. It's probably something I can fix in 5 minutes. So if you're trying to run it this second, don't panic. No need to wait on me to fix it for further questions.
All right. Well, I'm not seeing any other questions coming through, so I think we'll move on to Matt's talk about how he's used a feature algorithm to locate clouds. And if you think of other questions after Matt is done about Matt's talk or Scott's talk or just the Science Cloud in general, save them up and we'll catch them after Matt's talk. So Matt, if you want to go ahead and share your screen. Matt is another NCCS employee. He's been working there. I'm not sure how long you've been at NCCS, but he gets lots of odd jobs, I guess. And this is one that he had this summer to take a look at, which was, could this software algorithm that's been used by Facebook to look at faces be used to find clouds in some of the high resolution imagery. Go ahead, Matt.
Hello. I basically have been working on this utility, as Liz explained. It leverages the Facebook AI similarity search to parse through a set of images and ideally pull out the ones that are the most clear. Yeah. So the goal for this is specifically from science people to get an idea of, is this a kind of utility that you could use? Is this something you are interested in us developing more? And hopefully be able to get some hands-on tests if you have data sets of your own that you might, be able to give us feedback from how this works and what you might want in addition to what we already have. So it's a basic outlined workflow of what's going on under the hood. You're able to specify your location, so you pick a feature, and from NGA imagery, or theoretically any other imagery, it doesn't need to be NGA, just anything that's GeoTIFF really is what it's made for right now, and it's going to clip down to your feature. You're either specifying by lat long or UTM, a bounding box or a point, or even specifying your own image. But it's getting a region, clipping down, and then it's going to take a stack of images and it's going to run it through a FICE index, which is the similarity search, and it'll return a ranking basically. So you can get on a larger set of images, you can get a good idea of what your clear imagery is looking like and not have to bother looking at pictures of clouds that you obviously don't want to see. Most of this is currently implemented, not all. We have not yet done the back end for NGA imagery, so you actually do have to supply your own images with your region somewhere inside of it, and some more better optimized ranking mechanisms that are beyond just the FICE rank. I'm considering implementing based on performance in other tests. So none of that is yet implemented, but I'll keep showing what it can do as of now. So a few tests that I'm going to go through. This is a test of a mountain. Took an image from northern Alaska. This is just a random set of mountain images, all of the same spot. And basically you supply one image as a reference image and it finds the most similar images to it. So this is from, each search is from the same set. One specified the summer image, and as you can kind of see, I guess you can't see my mouse. Screen share probably. Can you see my mouse on screen share?
Yeah, we can see your mouse.
All right, cool. So yeah, this was a reference image, and if you notice, it pulls back the next two best images, which is pretty good, and kind of suppresses the cloudy and the snowy. The snowy is not what we want to get pushed down, but that's how it's going to work. So yeah, it pulls out what are clearly the best three in terms of comparison to this. And the same thing with the winter image. It pulls up all the clear snow images, suppressing the cloudy images, which is kind of the idea. Another test was a bigger set, so I didn't include the whole set of images here, but again, similar behavior. You have a clear image of the lake, or a lake, stream in the summer, and some images that look pretty similar to it, barring a couple of these over here. But it's pulling back, in general, the best images, and so you're not looking through pictures of clouds covering what feature you're looking for. Same thing with the winter images here. These are all, although kind of wild colors here, but no images, and it's pulling this back off of this reference. And we have another test. This is with a lake. We have the summer set and a winter set, and then just a little kind of side thing is you can take both rankings and just combine them, basically adding the weights based on where it was ranked. And obviously scaled, this might be an effective way to get better ranks. Down here is the added, and again, it's suppressing the incomplete and cloudy images the most with this, and providing the best, which is, again, the goal is to suppress the cloudy images as much as we can, get the clearest ones to the top to be represented to a user. Limitations with NGA imagery specifically, the colors can be radically different from each other. So again, it depends on what data you're using. The NGA data, some of these clearer ones have nice averages of 700, 800 for pixel values, while some of them, even the lake one here, has extremely high, between 5 and 1,000, or 5 and 10,000, excuse me. And so this is the ranking order. So comparing to the lake, it gives you the mountains before it even gives you the lake, and that in some ways beneficial because it's unrealistic that you're going to have different features. You're clipping only to one feature, but not always optimal. So to address this normalization, you can normalize your images depending on how well that works with your set. So if we normalize this image, still not the optimal result here, but it does bump the lake up a bit and gets rid of the image that was most liked before normalization. Basically what that's doing, normalization is rescaling from 0 to 1, so all the values from 0 to 1, so they're all the same in that regard. And this worked pretty well when we redid it on the lake set, for example. So it puts the cloudy image actually last. It recognizes the feature quite a bit more. Not so well with the mountain set, but again, this will vary, and this can be tweaked and combined with other mechanisms for ranking that we can use to optimize the output. So to test the code, I set up something, and I'll do a demo of this in a second to go through. So we'll kind of skip over this for a second here. But basically, if this is something that looks like it'll be useful to you, or you want more functionality from and then might use for work, I don't know. That's kind of what we're looking for. Also, if you have any machine learning things, GPU nodes are available on Adapt, so you might need a PI for that. I don't know, but that I included here as well because it's on the topic of AI machine learning. So I'll do a quick demonstration of it in use, so that way you can see how you can test it and how you can test it with your own images if you have some, or test it with samples that I did in the presentation. You see this terminal here? Probably, right?
Yep, looks good. We can see it.
All right. So from the slide, I didn't leave it up for very long, but you're going to run a series of commands to configure the environment. I'm kind of banging through these pretty quickly. Basically, you just want to load up the appropriate Anaconda environment, and then you can activate the FICE environment, and this is where you can use the script, basically. All right, so just real quickly, there's a bunch of configuration you can do with this, including where your data is stored, what you want the output to be called, where you want the output to be put. You can select what you're comparing to, because you can either have it compared to an image you're providing. So if you know which image is going to be the clearest from your set, you can supply that. Or you can supply your own image entirely and have it clipped to that and then compared to it. Specify location if you're not doing it by image. You can provide estimation, so you can have it automatically try and guess what's going to be the most clear and then do a search to that. You can zero your data, and then basically just run the command. So this is an example. We said the data is stored in ATT op other sim search examples, and then our stack. We can do the lake stack as a example, and we'll just do an estimation because I know which one it'll pick. The from file here just basically tells it that the images have already been clipped, so you don't need to clip them again. But if you haven't clipped them, you can adjust accordingly. Hopefully, it's pretty straightforward. And then just rank them. And so what this does, it configures it for you, gets all the images from GeoTIFFs, flattens them into arrays that the index can see. It estimated to this specific image, which is the clear picture of the lake from the slides, the very obviously clear one, and then it ranks them. So this is the same image, and then these are the rest of the set ranked, and this resembles, if I can find it, the top set that's here on the slide. That's usage. There's a few other things you can do. Just running it with -H gives you all the information to, configure it on your own. But yeah, that's all I got.
So bonus trivia, did you guys notice which lake it is? No? Well, it's Tulik Lake, just so you know. One question I had, Matt, so all of the images, though, you had to first clip them to be the outline of Tulik Lake, right?
Yeah, so, and this is automated in the script, so I don't have a way to pull down the NGA imagery from the NGA file system. But once you have the NGA imagery, you can then clip that down, and that's what I did. I supplied coordinates for the lake and for each of the other features, and just clipped down from that. And that is automated. So if you have larger images and you want to clip down to a feature and then search them, yes, that can be done.
And I guess you have to look through some of it yourself to find out what you think is the best one that would be used as the.
Oh yeah,
as
that
the
was what I
estimator?
did for testing.
Okay.
If you're using, again, NGA imagery, which is similar to what I'm running, using the estimation seems to work pretty well
Okay.
on the set that I tested. So you actually don't necessarily need to look. I mean, obviously you want to look through it at the end to see what it gives you, but this in the long term would be a more user-friendly interface, but we wanted to gauge, A, how much interest there is for a utility of this nature, and get an idea of what specific features people are looking to have implemented down the road, and then provide some samples so people can look at what's going on and, see if it's something of interest.
All right, so Mark Chopping has a question or a clarification. He says, so this uses multispectral imagery and a given good image for training. Is that right?
Basically, yeah. It's not really training. The algorithm is a nearest neighbor k-means search, as well as it does a dot product basically of the images, the reference image to the rest in the set, and it uses both of those to predict the most similar. But yes, you are, hold on, if I could see the thing here. I don't know why I can't. I want to go back to the question, but I can't see it. Oh, there it is. Okay.
Well, he's got some other questions written in there now, too.
Yeah, but yeah, you give it a good image if you're not predicting, you're trying to predict the best image. But yeah, if you know one to be good, then you can submit that, and it'll rank based on that as the reference.
And then another question to go along with that, can this locate corresponding imagery for specified periods of time? So I guess can you bound it not only by what's the best image, but also what's the best?
At this time, that's not automated. It's bounded wholly by the images you supply it. So if you're pulling clips only from an image bounded by time, then that would be the way to do it as of now. But in theory, we could implement that later once we start pulling the NGA imagery as an automated process with this.
Yeah, that's an interesting idea that you could then say, okay, here's my lat long, where my feature is of interest. I've given you a handful. Go, either through using EVHR to generate that imagery. Go find everything that we have in the database rather than asking the user to say, okay, here are all the images that I know we have. Now you tell me which ones I can see my feature in. So it's kind of like one step, like a phase 2 sort of option.
Yeah.
And then idea. Mark also asks, is there a published article or user guide?
No, there is no published article, and the user guide could be best described as the command I ran with the -H flag. And I will update this to maybe be a little more, I mean, it's pretty
yeah, it is, Matt, but I think what we would want... Better. Yeah, well, no, I think it's fine the way it is, but I think what we want to do is put something on the web which incorporates both the information in the -H and also a description of what it is, the code does.
No, well, that's true. But yeah, as of now, the -H is all that exists.
Right.
And the slides might go up. I don't know, there's not much information in the slides, but that tells you what it does.
Yeah, so we need a combination of the slides and the -H in a more user-friendly mechanism. This was actually a summer intern project I was going to get an intern to do that I couldn't find an intern for, and so since Matt started full-time this summer, I went, hey, you do this. And so we just did it. He did it in a couple of days, and we're really interested in finding out what uses there are for it, because this came out of a couple of conversations in the spring when I think Liz mentioned something about having all this imagery, but not always having the time to figure out which of the imagery was useful because it wasn't cloud covered, since what you see is % cloud covered, but not necessarily is my feature visible or not. That coupled with somebody mentioning FAISS, face, FICE. We don't know how to pronounce it. We're making this up. We just kind of came together and we thought we'd give it a try. So if it works for you guys, great. One of the things Mark Carroll has asked us to do is see if we can integrate this a little bit with EVHR, which would go from the NGA data to turn it into images that can be fed directly into this search. Mm. So that's something that we're going to start working on as well.
I think also this could be applied to the planet imagery that NASA is going to have available. So I'll just mention to everybody too, we're going to have planet imagery in the ABoVE domain in a couple key areas that we've kind of identified as areas where there's field work and airborne work, and we're going to download a bunch of this imagery, and it will be accessible to people on the Science Cloud through this NASA imagery data buy. And I could see something like this being useful for that too, where if you have, you have all the imagery and you know its location, but you don't know if it's cloudy on any given day. You might know, 20% of the imagery is cloudy, and the rest of the 80% are good, but you don't know where that is in your image. So it'd be a good way to kind of filter through that a little bit.
Yeah. What this doesn't do and is not intended to do is be able to say, hey, I'm looking for all lakes in this area. Mm-hmm. That's not what we're trying to do here at all.
This is not a feature search. This is where you're looking for, find the best images from that spot.
Yeah.
Mark Chopping has some other questions here too. He says, can users access or modify the Python code?
Yeah, so I was just about to mention that. The code should all be publicly accessible, at least as contained on a DAF. Under ATT opt other sim search, and under here there's the script called cloudclass.py, even though it's not actually classifying the clouds, but that was what it was called. And then the examples, and under examples, there's the NGA TIFF set that I use. These are the big strips of the more raw NGA data, and then I have a bunch of clipped examples that you saw in the slides. Yeah, and you can't edit the code that's in this folder, but you can copy it down, edit it to your heart's desire, and use it from there. Everything is specified basically by path, so yeah.
And Matt, you have this in the Git repo as well, right?
Not yet, but it will be.
Okay. Okay, all right. So we're going to set it up so that we could actually do, so that if you make modifications, we could actually push them back in.
Mark Chopping also notes
if I adjust the code also, I'll adjust it here. So like if I encounter an error or improve it with other implemented things, I'll just update it in here when it is confirmed working. That way you guys can poke it.
Mark Chopping also notes that many of the NGA records for digital globe data have cloud cover equals -999. So this could be useful when cloud cover is not specified, which is true.
Right. Yeah, so all the images I did, cloud cover was not specified. So, yeah.
Well, thank you, Matt. Anybody have any other questions about what Matt presented or what Scott presented? Or any other questions about the Science Cloud in general?
I have a couple additional comments if there aren't any questions. I sent you an email, Adriana, but it looks like the Intel GDB debugger requires setting Python path and some other environment variables that would significantly alter the default behavior of the nodes. So for now, I'm asking that anyone that wants to use it simply source a separate environment file, and I'm gonna put which one in the message of the day. But I can cut and paste it. Might as well cut and paste it here. 1 second. As soon as I roll the yeah, compiler vars. Yeah, that one line will enable everything in the Intel compiler suite. The base compilers, ICC and iFort, though, can be used without needing to do that. The other thing I wanted to mention, I don't know if USG disseminated the email, or maybe I just overlooked it due to O365 problems, but there are 4 new nodes out there for you guys to use. They're very similar to the ABoVE nodes, but they're the next generation operating system platform. It's Debian Stretch as opposed to Debian Jessie. You'll find an abundance of newer utilities installed on those nodes, and eventually we will probably need, we will certainly need to take the above and beyond nodes to the same rev of operating system. So in the interim, if you know, you have time to test any of your existing codes and such on those platforms, we do encourage that.
He says thanks. Well, let me ask also, it sounds like we might be done with our questions about this webinar. Are there other topics that all of you would like to see at future webinars? Or just other modifications that you think we should do on the cloud? Pat, I think when you have your elevation product ready, I think that would be a great webinar if you'd be willing to give one on that, to go through a little bit about what your product is and how you developed it using the Science Cloud and actually where people could find it on the Science Cloud. Pat says, sure, he'd be happy to talk about it. All right. Adriana wants to know, is G-Lite data still planned for going on ADAPT? I think there may be some G-Lite data already on ADAPT through what Annika has created, but I don't know if it's really very accessible. I think that's going to go into one of the DACs, and we should be able to pull it once it's in there. It's probably worth it for me to go back and check to see if it's made it to that DAC yet, because Annika had to get it sent to them first. I can find out about that.
Hey Liz, I know there's only 2 minutes left. Did you want to mention that the ORNL data is, for the most part, getting pulled now on a regular basis? Again, thanks to Matt.
Yeah, that's a good point. Matt has done a lot of other work for the ABoVE Science Cloud also, and so we do have all of the products that were stored at the Oak Ridge labs that were related to ABoVE, or if it's a product at NSIDC, which is Elvis data, that is now on the Science Cloud, as well as the L-band and the P-band data from the Alaska Satellite Facility. It's also on the Science Cloud. So Matt, you're already on the cloud. Do you want to just show people where it is in Pub Repo real quick?
To clarify, I don't know if I can check this and move it in not that much time, but I don't know if the directories that the ORNL data was pulled to are yet accessible to everyone. The data from NSIDC is still being pulled. So I think I emailed you yesterday.
You did, yeah.
So not all of that is down yet. We're still experiencing some issues there. It is pulling down, just not fast enough for us. But
and I think the L1B Elvis data is there.
Yeah, the L1 data is there. The L2 data is not, but it is coming.
Yeah.
And Liz, you were gonna create some links from ATT Pub Repo at some point, and we were gonna get some links created, so you don't have to drill down into where they sit. They'll end up in the Pub Repo directory.
Okay. All right.
To be visible from. So yeah, I guess we haven't quite. I sort of jumped the gun. We haven't quite finished all the bits and pieces, but it'll certainly be ready before the next webinar.
Yeah, so what is being pulled down and or has been pulled down that I know to be visible to people is the ABoVE archive, and that's where it's being pulled to. So in here there's the ORNL stuff, the NSIDC, and then
The Alaska Satellite Facility.
Alaska,
AFF.
yeah. I don't know. I don't know much about the data, but I know it's getting pulled, so. But
So
yeah,
that
that's
should
where
be
you
a
can
nice
find it. That
archive.
should be readable,
Mhm.
and it's still chugging along, so.
So
And
we
we can
hope
update.
people will start using that. And then I see Pat Burns had one last question, which is there are rumors that that NASA might get access to the 12-meter tandem X data, DEM data. I think that that is something that they're working on, Pat, but I haven't heard a lot about that in the last few months. So if I hear anything, I'll let you know. You may also want to contact Chris Nye because he seems pretty clued in on some of those things.
Hey,
All
Rose, I
right.
need to run, so.
All right. I was going to say, I think we're wrapping up here. Thanks, everybody, for calling in, and we'll probably have our next one of these in September. We'll take August off and then get back to things in September. Thanks a lot.
Thank you.
Bye, everybody.
Bye.